Here's another example that will give us an opportunity to apply what we know about right triangles, the theorem of Pythagoras, or Pythagoras is how I would prefer it, the theorem of Pythagoras, and what we know about finding square roots with our calculator. Let's suppose we have a house, and resting against the side of the house is a ladder. The ladder's 12 feet long, and the base of the ladder is 5 feet away from the base of the house. How far up the side of the house will the ladder rest? Again, couldn't we consider this to be an approximation of a right triangle, where we know the side opposite the right triangle, so we know the C side. It's 12 feet, it's the length of the ladder. We know one of the legs, but we're missing the length of the other leg. And we can use our theorem of Pythagoras to determine what that height is. We have 12 squared equals 5 squared plus b squared. So 12 squared is 144. 5 squared is 25. So now to find b squared, we first need to subtract 25 from both sides. So what's 144 minus 25? That's 119, isn't it? So we have 119 equals b squared, so b equals the square root of 119. Remember, anytime we're looking for a number that we can square to produce some particular value, we simply take the square root of that value, and that tells us the answer we were looking for. So use our calculator. We may still have 119 there in the display if we use that for the subtraction. Now just hit your square root function button, and we get 10.908712. So if we wanted to round that, approximate that to the nearest tenth, that would be 10.9, be 10 9/10. And so that's the height of the side of the house where the ladder will be resting. So we might say something like that. Ladder rests 10.9 feet up side of house. When you're solving applications, word problems, it's a good idea to put some words with your number to make the number